Welcome everyone. Today I am going to discuss a paper by Roy Kerr. The name of the paper is Do Black Holes Have Singularities? Roy Kerr is a pioneer in black hole physics. So, what is a black hole? Black hole is an object that has an escape velocity more than the speed of light. So that means if light goes in, it will not come out. So that's a black hole. So I'll read the name of the paper again. Do black holes, you know what a black hole is, have singularities? So there are points inside the black holes that we believe to have singularities. So what is a singularity? So first, before I try to answer that, let us try to understand what it means to say the distance between 2 points. Let's say I have 2 points and I want to find the distance between these 2 points. Let's say I have an x-axis this way and y-axis that way. So you go x squared plus y squared, and then I get distance squared. So you could find the distance between 2 points, and that is Pythagoras theorem. So far so good. But early 1900s, people found out that space and time are interconnected. They are together. They are not separate. This realization came to the physicists. So our distance measurement need to have a time component, because space and time are conjoined, like Siamese twins. So the very first person to come up with an equation with time involved was Hermann Minkowski. His equation goes like c squared t squared, time is there, minus x squared minus y squared minus c squared, something like that. But don't worry about the equation. All what you have to know is that Pythagoras theorem was modified and another component for time was added. So we have an equation for distance between 2 points, and time is also in there. That's above and beyond Pythagoras theorem. But then after Albert Einstein came up with field equations, now space-time is curved. So initially we had space only equation for the distance between 2 points. That would be Pythagoras theorem, we all know. And then we knew that space and time are combined, so then we have to come up with a new equation with time involved, and that was done by Minkowski. Now Einstein is saying space-time is not flat, it's curved due to gravity. The gravity would curve space-time. So you need to find another equation. So once Einstein came up with these field equations in general theory of relativity, within 2 months, a person named Carl Schwarzschild found an equation to measure the distance between 2 points, any given 2 points. And there's a long story about him. He was in First World War fighting in the trenches, and that's where he generated the equation. So you take Albert Einstein's field equations, he made the right hand side certain parameters 0 and some other parameters he simplified, and he came up with an equation for the distance between 2 points using Albert Einstein theory. So Carl Schwarzschild equation has space-time component, time component is there, and also curvature due to gravity also considered. Now there was a problem with this equation. What happened was there were 2 points in a black hole that where this equation would become infinite. There are 2 points. One point is at the center of the black hole. The equation between 2 points that Carl Schwarzschild came up with went to infinity. And there's another point called Schwarzschild radius, r equals rs. It went to infinity again. So there were 2 points that the distance between 2 points would be infinite. How could the distance between 2 points would be infinite is the question. So that we say the equations break down. It's undefinable. So that's where we call a singularity. So far, so good. But the question was, would that really happen in nature? Are there points like that? And in 1963 paper, Roger Penrose showed with his concept called trapped surfaces, singularities are inevitable. If you have a black hole, they're going to form. He showed that in 1963. And he got the Nobel Prize for that. But then what happened? Roy Kerr is saying that the black hole that Carl Schwarzschild considered and Roger Penrose considered are not rotating. They're not rotating. But the black holes are formed from stars. When a star explodes, whatever the matter that's left, the core would collapse all the way to a black hole. Now we know all the stars, all the planets, everything rotates around its own axis. Our Earth is rotating around our axis, and the sun is rotating around its own axis. So there is no star in this universe that do not rotate. So everything rotates, and when it becomes a black hole, it has to rotate. That angular momentum has to be there, so it is rotating. So Carl Schwarzschild equation was not valid, and that was the point that Roy Kerr made, and then he came up with a new equation to find the distance between 2 points in a rotating black hole. So now first we had Pythagoras theorem for just space, and then Hermann Minkowski came with equation to find the distance between 2 points considering time, and then Carl Schwarzschild came up with an equation considering space, time, and gravity, but his black hole that he considered or would appear in his equations was not rotating. So that's not realistic. All the black holes have to rotate because all the stars are rotating, and the star becomes a black hole. That angular momentum has to be there. So a new equation was needed, and that was provided by Roy Kerr. So in the Roy Kerr equation, the singularity is not a point, it's a ring. So what Roy Kerr is saying that any light beam will not hit that ring, but it will be asymptotic to that ring. So there cannot be a singularity point. And that's the point that Roy Kerr is making. Then what about the singularity points that appear in Carl Schwarzschild's equation? But Roy Kerr is saying that's not realistic. You did not consider rotation, and all black holes have rotation. So that's not a existing condition in this universe. So then there cannot be any singularities. Now I don't know whether there are loopholes, any errors in this paper. I'm waiting to see the answer from Roger Penrose, and if I see any rebuttal from Roger Penrose, and I would do a video on that. Thank you very much for listening.